The graph below shows a rectangular sum of n equals 8 rectangles to approximate the area under the line from x equals 0 to 2. So we're trying to estimate the area underneath this line, which would be this, but we're going over it. This is an overestimate. See how there's more rectangles are sticking out the top of the line. So we're going to get an overestimate. That's why it's just an approximation. It's not the exact area under the line. First question, is this a right-hand or left-hand sum? This is a right-hand sum. How do you know? Well, see how each rectangle, like this little rectangle right here, he is hitting the line in his upper right-hand corner. This here, I'll do the one over here as well. Let's see, right here. This rectangle right here. What part of him hits the line? His upper right-hand corner. So each of these rectangles, every one of these rectangles is hitting the line in his upper right-hand corner. So these are called right-hand sums. You can have rectangles hitting on the left or the right. Now, what's the equation of the line? So they mean this straight line right here, which is going to be y equals mx plus b, right? Any line, that's the equation. B, do you remember B is the y-intercept? It's where the graph hits the y-axis. This is the y-axis, x-axis. It hits right here at 0. You see how this line, let me get rid of this right here. This line is hit, it goes right through the origin, 0, 0. So the B is just 0. The y-intercept, the place where the line hits the y-axis is at a height of 0. And what's the m? You remember the m? That's slope. That's rise, slope. That's rise over run. Okay, so what's the rise and the run? Well, you just go between any 2 points on the graph. It doesn't matter which 2 points. Like I'll just pick a couple. Now you get make them nice, like make like that, which is right on a grid line, and like that. See, those are right on the grid lines, no guessing about it. So how do you get from one point to you go up 1, 2, that's the rise, up 2, and you go over 1. That's the run over 1. So up 2 over 1 to get from any point. I could have started with this point, go up 2 over 1, up 2 over 1. That's what the line does. He rises and runs 2 over 1. That's 2 over 1x plus 0. So that's just y equals 2x. There we go. Equation of the line. Now, last one. What's the value of the sum? They mean the sum of the rectangles, which is going to be an overestimate for the area under the line. So how do we find the sum of the rectangles? Well, we're going to take these rectangles and take a close look at them. So, like, here's the first one. So, let me see. If I can make my pen in and lower. I don't think I can. All right, I'm gonna mess with it. No, it's good enough, whatever. All right. So, right here, right? See this rectangle? Boom, 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 boom. Okay. So, what's the area of a rectangle? Area of right. We have a whole bunch of rectangles here. What's the area of any one rectangle? It's just length times width, one side times the other, right? Base and height, length and width, whatever we're going to call it. One side times the other. How tall is that rectangle? Looks like it comes up to a height of zero point 0.5. It goes halfway up. Okay. And what's the width? It looks like the width is a fourth or 0.25 width. How do I know that? Well, because there's four of them. There's another one right here, number two. And then there's number 3 right here. And then there's number 4 right here, all the way to 1. So that's a fourth, like a quarter, which is 25 cents. Each of these rectangles has a width of 0.25. And they have different heights. Like what's the height of this one? It's 1. What's the height of that one? 1.5. What's the height of this one? 2. Then we have another one here. And the height of that one appears to be, it's got to be 2.5. The height of the next one is 3. And the height of this one is 3.5. And the height of the last one is 4. Okay. So for each of these rectangles, then, so we're going to have to add up all those areas of those rectangles. What's it going to be? It's going to be um, So it's going to equal, it's going to be the height of 0.5 times the width of 0.25. That's for this first little rectangle. That's his area, right? Length times width. 0.5 high, 0.25 on the bottom. Plus, then we get the next rectangle. And that one's going to be 1 times 0.25, right? Because if you fill this one in, its height is 1. Again, its width is 0.25. They're all the same width on the bottom. The next one is going to be a height of 1.5. We're just going up the line here. Times a width again of 0.25, etc. Right? That's the third rectangle. Again, it's 0.25 width. Height is 1.5. So notice they all have the 0.25. So to save time, what we could do is we could say, look, let's just factor out that 0.25. They're all going to be multiplied by 0.25. And then just add up the heights, right? Just add up the 0.5, like this one, this one. Maybe I shouldn't do it that way. This one, 1, 1.5, 2, 2.5, 3, 3.5, 4. Is that the last one? I think it is. All the way to 4, like that. Just add those up, right? I just went all, it goes all the way up, check them off all the way to 4. So then it's going to be 0.25, the total area of all those. Add these up. What's that going to be? Let me tell this. You use Desmos. We want to 1.5. That'd be 3, 4, 5, 6, 7.5, 10.5, 11, 12, 14, 18. 18, but then times a fourth, 0.25, half of that be 9, half again be 4.5. Right, that's the right answer. So that's the total area of all the rectangles is 4.5, which is more than the area under the line, right? Because it goes over. They're sticking above it a little bit. And so there we go.